All right, folks, welcome to our very last video lesson for Chapter 4. In this lesson, we're going to focus on what's called an arithmetic sequence. An arithmetic sequence is just going to be an application of linear functions that we've been focusing on for the last two chapters. In general, we're going to talk about an arithmetic sequence, but what is, first, a sequence? So a sequence is an ordered list of numbers. So you can see here I have a sequence of 5, 10, 15, 20, 25. When we talk about the word ordered, there is obviously some order to it. So these are placed in a certain order because what we're going to try and do is recognize that there is a pattern between those numbers. Starting with the first number 5 and looking at the other numbers, okay, they're placed in that order because they follow a specific pattern. Each of these numbers is what's called a term. So a term is going to be a specific number within our list of our sequence. So for example, this would be the first position of the first term, third position of the third term, and we can talk about any random position, which is called the nth term. So our goal for today is to focus on what's called an arithmetic sequence. So like I said before, an arithmetic sequence is just simply going to be an application of a linear function. So an arithmetic sequence is an ordered list of numbers where the difference between the consecutive terms is always going to be the same. So consecutive terms mean the terms that are right next to each other. So if I use, for example, the problem that I had before, we have 5, 10, 15, 20, and so on and so on. Okay, my first term would be 5, my second term is 10, my third term is 15. So if I look at the difference between these terms, so for example, if I take 5 and 10 and subtract them, what I'm going to get is the number 5. That 5 represents the difference between those two numbers. And now if I look at my other terms, like let's say 10 and 15, those would be considered consecutive terms because they're next to each other. Notice that that difference is also 5. 15 to 20 is also 5. So this is where we talk about the ordered list in the sequence. Notice that these numbers are following a pattern of adding 5 every single time. And I can continue this pattern and then make predictions that if I were to add 5 continuously, I can then find my next couple terms. This idea of adding 5, or we could do the opposite of subtracting 5, this is what's called the common difference. The common difference is the difference between those consecutive terms. The reason why it's called the common difference is because it happens between every pair of consecutive terms. So you can take a look here, kind of like a biology experiment here. Here I have 1, then I go to 2, then I go to 3, then I go to 4, and then a 5 little atoms there. So if you look at the common difference here, the difference between these terms would be plus 1 every single time. And again, it's called a common difference because it is the same thing that we are adding or potentially subtracting between every single term. All right, so using this idea of recognizing an arithmetic sequence, what we're going to try and do is first look at our sequence, our ordered list of numbers, try and figure out that common difference, and then use that to write the next 3 terms. So let's say I were to give you a pattern of -7, -14, -21, and -8. So our first term is -7, our second term is -14. So what I want to do is find the next 3 terms. So if I were to continue this pattern, what would they be? Now what I have to do in order to do this is to figure out what is the pattern going on between these numbers. When I say the pattern, that's referring to the common difference. So I'm going to look at the first 2 terms, okay? We'll label this the first term A1, like the steak sauce, and the second term A2. If I want to find the common difference, what I'm going to do is take the first 2 terms and subtract them, okay? By subtracting here -14 minus -7, that's going to tell me what the common difference is. Now subtracting those, I should get -7. What -7 means is that it's going down 7 every single time. Okay, so if I were to continue this pattern, if I were at -28 and I were to subtract 7, that should give me my next term of -35. And if I were to subtract 7 again, I would get -42. And subtract 7 again, I'd get -49. So these would be my next 3 terms, and I figure that out by determining what that common difference is. That's the pattern that we're seeing. All right. Next one, I got -12 and 0. So again, if I want to find the common difference, I'm going to look at the first 2 terms. I have my A1 and my A2. I'm going to subtract those 2 terms. Okay, the second one minus the first. Okay, they're both 0 minus -12. So by Canceling out those negatives, I'll get 0 plus 12, which means my common difference is 12. Now notice here it's positive 12. So that means the pattern I'm following is plus 12. So I'm going to keep adding 12 every single time. So if I go from 24, my next term would be 36, then 48, and then lastly 60. Those would be my next three terms by following that common difference of 12. All right, now, how does this relate then to linear functions? So what we're going to do is look at this on a graph. So what does an arithmetic sequence look like on a graph? Okay, so this would be my sequence 4, 8, 12, 16, and so on and so on and so on. So think of A or 4 as my A1, my first term, A2, my second term, my third term, and my fourth term. So to kind of make a table, my first term would be 4, my second term would be 8, my third term would be 12, my fourth term is 16. So if I were to plot these as points on a graph, think of each of these as a coordinate, sorry, not a coordinate, an ordered pair of 1, 4, 2, 8, 3, 12, and 4, 16. All right, plotting these on a graph, if I go 1, 4, that means right one up 4, 2, 8, 3, 12, 4, 16. Notice the pattern that it follows is a linear pattern. Okay, now based on the pattern, this would be considered a discrete graph. Okay, but in general, you can see I'm not going to draw the line, but I'll just draw it as a highlighted. You can see that it forms a linear function. Okay, it is a discrete graph because we're looking at specific points on my graph. But again, how does this relate to what we've been talking about? An arithmetic sequence represents a linear function. All right, so the same example in reverse. Now you're given the points on a graph, and I want to know, does this represent an arithmetic sequence? So if I look at the points, I have the points of 1, 15, I have 2, 12, I have 3, 9, and 4, 6. So does this represent an arithmetic sequence? So really the pattern that I have, or how I judge the pattern, is based off of these numbers here. Think of these as the outputs. Okay, it's kind of like going back and asking you guys, does this represent a linear function? So what I'm going to do is I'm going to take my first two terms. Just like I did before, to find that common difference, I'm going to subtract the second term and the first term. So I'm going to do 12 minus 15. That means the common difference here is going to be negative 3. So my goal then is to figure out, does negative 3 follow, or do the numbers follow this pattern every single time? So starting at, and I'll show it down here, starting at 15, if I subtract 3, that's going to take me to 12. If I subtract 3 again, does that give me 9? If I subtract 3 again, does that give me 6? Does it follow that pattern? In this case, yes. And the reason why is because it has a common difference of negative 3. If this number were to be different, if I see negative 3 and all of a sudden it changes to negative 4, then negative 5, if the common difference changes, is not consistent or constant, then it would not be an arithmetic sequence. All right, now this whole unit, this whole chapter has been on writing equations of lines. So we looked at writing things in slope-intercept form, writing things in point-slope form, writing things of lines of parallel and perpendicular lines. Now what we're going to do is try and represent these arithmetic sequence. So again, an arithmetic sequence is just simply a linear function. Okay, so what I have here is a equation for how to write an arithmetic sequence. If you recognize the form, this equation for an arithmetic sequence is just simply point-slope form written to follow an arithmetic sequence. The only difference is it's written like this: y equals y1 plus x minus x1 times d. So think about d as my slope. D represents my common difference. You have x, which represents the number of term that we have. Okay, x1 in this case is going to represent my very first term, or sorry, just the number 1. y1 here is going to represent my very first term. I'm sorry, I said that wrong. And then my y value here would be any random term. So a to the n represents the nth term. So for example, I could ask you guys, what would be the 100th term? Then I would say, okay, what is the 100th term? So what this means is that n would be the number 100. A1 would be my first term, which would be whatever my first term is in my sequence, and D would be that common difference. So what it is just applying point-slope form to an arithmetic sequence. So what we're going to do in this example is take our arithmetic sequence and we're going to write that equation. We're going to try and simplify it down, and then we're going to try and find the 50th term. So A50 means the 50th term. So in my in my sequence here, I have 14. 14 is my very first term. Okay, when I look at the numbers, so again, if I compare 14 to 11, my first two terms, the common difference here, I'll just write up top, would be 11 minus 14. So that common difference here would be -3. All right, so my arithmetic sequence is this. A to the n equals A1 plus, in parentheses, n minus 1 times d. Okay, so what I'm going to plug in is I'm going to leave a to the n. Okay, a to the n represents any number term. A1 represents my very first term. So in this sequence, my first term is 14. I'm going to write plus then n minus 1. I'm going to leave the number n in there, minus 1, and then times my common difference, which is -3. Now be careful here with that -3. It means multiplication. Now what I'm going to do here is I'm going to simplify this because I don't really like how it's written. So to simplify, I'm going to take -3, I'm going to distribute that. Kind of distributing it a little bit backwards on how it's written, but that's okay. So I've had a to the n equals 14 plus, now -3 times n would be -3n. -3 times -1 would be +3. What I'm then going to do is combine my like terms, and I'd have a to the n equals 17. That's 14 plus 3 minus 3n. And this right here would be my arithmetic sequence, or my equation, I'm sorry, to represent this arithmetic sequence. My goal then would be to find the 50th term. So to find the 50th term, all I'm going to do is take the number 50 and plug it in where n goes. So I would do a to the n, so a to the 50th term would equal 17 minus 3 times